SAT 22 for week 25. We've got a multiple choice question here that reads, two identical rectangular prisms each have a height of 90 centimeters. The base of each prism is a square, and the surface area of each prism is k centimeters squared. If the prisms are glued together along a square base, the resulting prism has a surface area of 92 over 47 times k centimeters squared? Okay. What is the side length in centimeters of each square base? All right, how did we do on this question? Well, we did pretty good. I'm going to say somewhere around really close to 73% of us got answer choice, whatever this color is, B, which was the correct answer. And you can see that the next closest spike is 15, not even really even close with answer choice C. And we thought it was pretty firmly in the medium category as far as difficulty goes. All right, let's dive into the solution here. All right. And probably to help make sense of what's going on here, I might sketch myself a picture of some rectangular prisms. So I draw myself a little rectangle here, and then I completely cheat by just duplicating this guy. Doop. Maybe offset them by a little bit. Throw some dashes for the hidden sides. Okay, so here is one of my prisms, and then I'm supposed to duplicate this thing, so I have two copies of it, so dupe. And wow, I did a fantastic job of doing that, right? See this little thing right here? Just color it in, and then it looks flawless. Okay, so the next thing about this is, do you know what the formula for the surface area of a prism is? For the surface area, well, wait, don't we have a little tiny formula chart? Let's take a look at this formula chart real quick. So coming back to the main page for the SAT questions, we do have various formulas that are given to us for free. And you can see that you've got area, circumference, Pythagorean theorem, special right triangles, and volume, but you don't have any surface area. So for whatever reason, SAT is requiring that you know the surface area formulas by heart. Okay, no problem. So, of course, you could just break this up into its component little pieces and add those pieces together, but this question I think is going to be far easier if we just know what the formula is. I'm going to call it a capital letter T here for total surface area, and in general, it is the perimeter of the base multiplied times the height, and that essentially is going to give us the lateral surface area, and then we would have two bases. Whatever the shape of the base is, you plug in the area formula for that shape. Okay, so let's be a little bit more specific here. We know that these side lengths here are going to be S, so I can kind of simplify this just a little bit because these things are squares. So RT is equal to perimeter of a square is 4 times S, and then multiplied times the height, and then the area of one of these squares is 2S squared. Perfect. All right, so now it's just a matter of plugging some stuff in, some numbers that were given, and the only thing that we're really given here is the height is supposed to be 90 centimeters, so we can put 90 right here, and this is just for the singular prism, and that whole thing should be equal to K. So instead of using T for our surface area, we're just going to call it capital letter K is equal to the perimeter of the base, which we said is 4 times S. I don't know what S is, but I do know that the height is 90 plus 2 of our bases, and that's side squared. So there's maybe one little bit of simplification that we can do here, so that we can multiply the 4 times the 90, get 360, so K is equal to 360S plus 2S squared. So when I look at this equation, there's not a lot I can do to it. I can probably graph this thing, but it is a parabola. You can imagine this K as a Y and this S as an X. It would make a parabola that's kind of skinny, especially since you got this 200 or this 360 that's right in here, and it has an infinite number of solutions. In order to figure out what S is equal to at this point, I need another equation to solve the system of equations by. And that's the fact that we would have two of these prisms glued together at this little base that's right here. Now, whenever I go to find the new surface area, you might think that all you have to do is just double the previous one. Well, if we just double the previous one, then this wouldn't be the fraction 92 over 47. It would just be 2 times k. And the reason why it's not straight up doubled is because this base that gets glued together on both of them is excluded. You don't even use it. It's not even part of the exposed surface. And you still have two bases here. You still have the original top base and this new bottom base, but then your height is going to change to 180 because you have two of these 90s strung together. Okay, so I'm going to clarify that this is one prism. And now let's find our surface area with two of them. And two of them together is this 92 over 47k. What a weird number. Is equal to, this time, our 4s times not 90, but 180 for the total height of the two 90s glued together. But we still have 2s squared for our two bases. And then just like before, only thing that I would do probably is multiply my 4 times 180. And essentially that is just 2 times the 360 that we had in the previous one. So that's 720. So simplifying here, I got 920 over 47k is equal to 720s plus 2s squared. And I have my second equation that forms my system of equations. And this one is for having two prisms. Okay, how do you solve a system of equations? Well, it's the usual ways. You can solve it by graphing, you can solve it by substitution, but since you have two parabolas essentially, because you've got squares here, elimination, that may not make sense because if I try to eliminate, if I try to subtract these equations, sure, these two s squares would disappear, but I would still have two variables. I'd have the k's and I'd have the s's, so then I still couldn't solve it. So substitution or graphing is probably the way to go. And so you're thinking, oh my God, Desmos, lifesaver. So here, let's take a look at how Desmos actually does not save lives in this instance. All right, so let's pull this guy up. All right. But I'm going to side by side it because who's going to remember those equations? A whole bunch of nobody. Okay, now just picture this whenever we go to type this in. The k is going to be the y and the s is going to be the x. So it's going to be y is equal to 360. Whoa, that is not right. 360x and then plus 2s x squared plus 2x squared. All right, I'm going to pause here for just a second, maybe full screen this, and just take a look at this parabola. You can't even tell it's a parabola. Oh, there we go. There's the other side of it. Keep scrolling, keep scrolling. I'm sure that we'll reach the vertex point eventually, right? So this is kind of the main issue with this parabola in particular. Anyway, so let's type in the second one. So the second one here was, yeah, you could still type it in with this 92 over 47 business. It should still work just fine because Desmos can handle it, including the version of Desmos that you get on the actual PSAT or SAT test. So 92 divided by 47, make sure your arrow out of that, k, but it's y, right, is equal to 720x plus still that 2x squared. All right, and this is our blue parabola that's going on here. And then once again, I'll full screen this thing and then try to take a look at where these two things intersect. And this is where the issue comes in, is trying to find where these two things cross each other. Now, one of the things that you could use to help you is the fact that it is only supposed to cross each other at these four possibilities, 4, 8, 9, and 16. So it would give you something to look at. But still, it's because of how skinny these parabolas are and the numbers that we're dealing with, it is rather difficult to find the point of intersection. Okay, so there is another way to do it, and that involves actually just doing a little bit of substitution, and so you just have one equation to deal with. So let's take a look at what that substitution would look like. So we have our second equation, which says 92 over 47 times k is equal to all this. What I'm going to do is I'm going to take the value of k that we got from the first equation and just substitute it in for k in the second equation. That's going to get rid of our k altogether, and we'll just have an equation that has s's in it. So this new equation after substitution is 92 over 47. Open up some parentheses, replace k with 360s plus 2s squared. That should be equal to the rest of the 92 over 47k equation, which is 720s plus 2s squared. Okay, so yeah, you can solve this one by hand, and I'm going to do that here shortly, but it is probably going to be faster to solve this one on Desmos uh, with this version, not with the two separate parabolas where we're trying to find the point of intersection, just because of how those parabolas look. I mean, take a look at it. So anyway, what we're going to do is we're going to hide these two guys and instead type in the substituted version of this, 92 divided by 47, arrow out, open some parentheses, and it is the top equation there, which is 360x plus 2x squared, perfect, is equal to, and then it's now the second equation, or at least the right side of that equation, 720x, and then plus, that's a minus, plus 2x squared. All right, so now this is so much easier to try to solve because all we're dealing with is a single variable. Now, I will point out that the solution to the equation that we're seeing in box 3 actually has two vertical lines. This is not a parabola. The reason why this is not a parabola is because this lacks the y to make it a function. You're not pairing up two numbers. Technically, this should not be vertical lines either. It should just be two dots on the x-axis. But hey, it does give us a way to very quickly see what these solutions are. So you can see that one solution is 0 and the other solution is 8. And if I'm not mistaken, 8 was one of our answer choices, which is answer choice B. And so you're done. Could you have done this by hand? Yes, absolutely, but it would just be a little bit more time consuming. Let's go ahead and take a look at what that math would be. I would suggest if you're solving this thing by hand is to take this 47, instead of distributing this improper fraction through the first set of parentheses, multiply this 47 to the other side. That way you're not having to deal with any of these complicated fractions. So 92 parentheses 360s plus 2s squared parentheses is equal to 47 times 720s plus 2s squared. Okay, that's better. And then I'll have to distribute the 92 through both by the left-hand side. And in order to do that, I'm definitely going to type that in. So 92 times the 360. That's wrong. How about 360? Okay, so we got 33,120. 33,120s plus, if it was 90 times 2 is 180, this is going to be 184 s squared is equal to, now let's do the same thing with the 47 and the 720. Hit enter on that. 47 times 720 is 33,840 plus 2 times 47, that's 80, 98, I believe, no, 94 s squared. Okay, and then you just combine your like terms. Let's get everything where the s squareds are bigger, which is over here on the left-hand side. So I'm going to take this 184 and subtract 94 from it. 184 minus 94 gives us a nifty exact 90 s squared. And then I'm going to subtract the, oh, I forgot an S on this one. No, I didn't. There was just a little bit of lag with my Apple Pencil. Anyway, so there's an S there. I've got to subtract this guy over. It is going to be negative because this one is slightly bigger. And I think that like the 33s could kind of cancel out. I could just maybe subtract 120 and the 480. But hey, I've got these numbers. I said 480, 840. I have the numbers right here on the screen, so I could go ahead and subtract them. So 120 minus, and then 840, 40, negative 720. S equals 0. Now it's a very simple quadratic to factor. No AC method here. It's just GCF that you pull out of this. And one of the factors that you're going to pull out of this is a factor of S. They both share a factor of 90 as well. You could just divide both sides by 90 to reduce it, but since we're doing a little bit of factoring, I'm going to pull it out. So 90S, open the parentheses. This would just be an S because 90S times S is 90S squared. And then minus, I just got to figure out whatever 920 divided by 90 is. Well, it's the same thing as 72. What did I say? I don't know. 720 divided by 90, but that's equivalent to just 72 divided by 9, which is, ooh, it's an 8 is equal to 0. Why is this significant? Well, applying the zero product property, this first factor of S on the outside implies that S is equal to 0. Remember that solution that we got? That we promptly threw away, and then the other one is S minus 8 is equal to 0, which implies that S is equal to 8. So there you go, you got your actual solution, which is what we wanted. Now, I have it on good authority that quite a few people solve this by just straight guessing and checking, which probably is more efficient to do than all the algebra that we just did here. So let's look at a way to have Desmos kind of efficiently help us guess and check, especially since we had 4 answer choices here. So it's still, I would say, dependent upon the equations that we have here, as in we still used the formulas for the surface area, but instead of actually having the S in there, we would have, starting off, a 4. We would assume the side lengths of the square are 4 by 4 and just plug it into the formula here and see what the actual surface area of that thing is going to be. So here, let's actually do most of this over here on Desmos. And I don't need all of the other calculations. I'm going to go ahead and keep I'm actually going to keep the little graphs and stuff, but I'll get the numerical parts going. Okay, so here's the crazy thing that I'm going to suggest that you do. Actually do this dynamically. So we have a side length that we're going to be able to vary. If I just set my side length to, well, the first answer choice was 4. So I'm going to say S is equal to 4. It'll turn it into a slider for us and just keep it as 4. We can go back up there and change it as we see fit. Okay, so the first calculation was the perimeter of the base, which is 4 times S, times the height, and the height was times 90 for the first one. Okay, so there is the lateral surface area, and then we would just have to add in 2 bases, which is plus 2 times S, and then squared. Okay, so here is the total surface area of one of those prisms. But then we're going to glue 2 of them together, and like we said, it's not just twice as big as this. It's actually the same calculation, but where there's a 90, it's going to be twice that size. It's going to be 180. So I'm going to type the same thing in again. So 4 times S, but this time times 180, and then plus 2 S squared. Okay, and then I have my second number here. And what I want to be able to do is remember that the second number should be this crazy fraction of 92 over 47 times the previous one. So let me show you how we can totally simplify that. Let's say I go, come on, Desmos, there we go. I type in my fraction, 92 divided by 47, and then arrow out of here, and then I'm starting to type this in. Instead of actually typing the number, which you can totally do, the 1472, watch what I'm about to do. I'm going to go up to this line 5 here where this calculation is, and right at the start of it, I'm just going to call that thing k. I'm going to say k is equal to that number. So now it just basically stores that value as k for me, and so when I come down here to line 7, I can just type in the letter k, and now it takes the previous k value and multiplies it times the fraction 92 over 47. And I can see that these two things do not match, and therefore the side length could not have been 4. Okay, so now I just come straight up here, and the next answer choice, I believe, was 8. So I will delete the 4 out. Everything freaks out until I put an 8 in, and then everything goes yay, because I can see pretty clearly that these two answers are in fact the same. And there's your answer. And you know, if 8 didn't work, you could come straight back up here. What was another one? 9 was the second most popular answer, so let's just see what happens when we plug in a 9. So I throw in a 9 in here, and you can see that these numbers are fairly close, but you know, not close enough, especially since we want them to be exactly equal to each other. And then just for the sake of thoroughness, we'll go and type the last one in there, which was 16. And yeah, this one was, just it looks like it, over 200 off, so definitely not the correct answer. Let's go back and in this video with the correct answer plugged in there for S, and that should do it, I think, guys.